Okay folks, so we're just going to take you through the rest of the assembly of this coffee grinder. So we can see there that we've assembled parts 1, 2, there's 2 twos, 3 and 4. Okay, so sorry, there's 1, 2, 3 and 2 fours. So we can see there that's the general gist of what it looks like. If we flip back here to the actual drawing itself, we can see the assignment itself. We can see we've built up the vast majority of the housing. We've put in a few more pieces. So the next one I want to put in is this shaft here, this horizontal shaft. Now this horizontal shaft, I believe, is part number 12, top spindle, diameter 8. And again, identifying the different parts is just really figuring out what they are. I know the part 8 is a long piece. It's 240 millimeters long. It's the longest shaft I have. And if you look at the base piece, you can see that it is 220 millimeters long. So it extends out longer than the base piece. It's the only shaft that's that size. The other shafts are 180, 157, and so on. So again, it's just using a bit of common sense to identify which shaft is which. So let's go back to let's recognize is part 12. Yep. So let's go back to SolidWorks and let's open up my assembly. And then we'll go click on Insert Components, and I'll click on Browse and find the components there, or any open document is displayed here. So I've just completed part 12, so it's displayed there. So I'm just going to drag it in. You can see that it's oriented in the wrong direction. Okay, so that's not particularly useful. But I can come down here to this little drop-up menu or pop-up menu, and you can see that I can rotate it around a number of different axes, so X, Y, or Z. The best way to do this is just to play around with them. Experience taught me it's the Z axis, okay, but you can play around with the Y axis. The Z axis, if I click on the Z axis, you'll see it actually orientates completely wrong. Okay, so it came in like that. Click on the orientation with the Z axis, and now it relieves that the shaft is running parallel to the axis of revolution. Okay, so when I left click there, that'll just simply drop that piece in. Okay, and then the next thing to do is to go and select mate. Now we want to go into mate, we want to click on the shaft, and then we want to click on the inside of the hole, and that'll put up a concentric mate between the two. Now the shaft is free to move freely, just exit of mate. That shaft is free to move freely through the entire thing. Okay, so we can see that the shaft is smaller than the hole. Okay, and why is that? Well, it's that size because we have a number of different bushes which are similar to a bearing, but they're a solid piece of material. They're normally made from a different type of material than, say, the shaft or the housing would be. So they'd be harder than the housing, so that the bush can push in and be a limit fit, and there'd be obviously some sort of anti-friction properties that they would be able to allow the shaft to move freely. So again, you're not traveling at huge speed here, so it's not going to create a huge amount of friction, so it's not going to need a full bearing, but a bush will do equally as good. So you can see there that there's two bushes. Okay, we can't really see where they are from the outside, but we can see if we zoom in there nice and gently, you can see that the bush is on the inside here. So we can assume that the other one is on the far side. So there's two bushes there. Okay, so let's just go down and look at our parts. We have a vertical spindle bush. So a vertical spindle, vertical means going straight up and down. So that's not it. So it's definitely not part 4 because this is a horizontal shaft. And then we see bush for top spindle. So 2. So part number 5. So I'm going to go back to my SolidWorks assembly, and I'm going to go to insert component. I had done part 5 a previous day, so I'm going to go down here and find part 5. Insert part 5, click on open, drag it in. Again, I can rotate the sizes of it. I can just again go and figure it out. Again, Z would be a better job there to be able to do it. And I just simply click it into space. Now we can see that if I click on the mate command and I click on the outside of the diameter of the shaft, I click on the inside of the hole, we can see that it adds concentric mate. Then if I click on the inner shoulder of the bush and the surface, the inside surface of the grinder, I can click on the green tick and that'll put a concentric mate on it. Okay, so that is pretty much that. Okay, now to repeat that, so we just simply find the last part I brought in, which is part number 5, hold down the control key on my keyboard. It's normally the bottom left hand side of the keyboard, and I hold down the control key, I left click and drag and drop it into the graphics area, and that just pulls out a copy of the original part. Again, I click on mate and I click on concentric. Okay, and concentric, so the two inside shafts. Okay, and if I click on that button there, if you just leave the mouse over for a second, it'll show you flip mate alignment. So we flipped the mate alignment. It came in like this because that was the orientation of the other one, but that's the wrong way. So we need to flip it, that the inside shoulder is the other side. I can do it down here as well on the left hand side in the menu. You can see here mate alignment, and I can say flipped. Okay, so there's two places you can do it, on the pop-up menu or on the left hand side properties menu. Click on the green tick, drag it back so I can see it. I'm going to click on the surface of the perfect grinder, the housing, and the inside of the shoulder of the bush. And now we have our bush in place. Okay, so now you'll see that our shaft is still able to move freely through. Okay, so we'll leave it freely for the time being. Okay, the next thing that I'm going to put on there is, if we look here back to our drawing, we can see that we have a handle. So the handle is part number 4. So I'm going to go in and I'm going to assemble part number 4 in place. Insert components, browse, and I scroll down and I find assignment 4, part 8. Let's just check that. It is part 8, pardon me. Part 4 was this vertical shaft. So part 8 is over here. Yeah, okay, so it's part 8. Go and find it. Part 8, click on open. Again, it comes in like that. We can just flip it around in the y-axis and that'll make it move around. I left click on it anywhere in space and that is going to drop it there for me. Okay, so you can see it's a wee bit off center, but that's grand. I click on the mate command from the assembly toolbar. Click the inside of the hole of the handle and the outside hole of the vertical shaft. Click on the green tick. Now we need to bring this back and we want to align that to the outside of the bush. So I'm going to click on this surface, the outside of the handle. I'm going to click on this surface, the outside of the bush, and click on the green tick. Brilliant. Okay, so now what I'm going to do is I'm just going to click on the outside of the handle and the outside of the shaft and bring the two joints together. Okay, so something like that. Okay, so we're starting to build up nicely here. Right, the next part that we have to get is the cone driver. Okay, so we have 2 cone drivers. So we have driver friction cone. So it's part 7. There's 2 of them. One of them is orientated, if we look in the base, in the housing, and the other is concentric to the main shaft. Okay, so what we'll do is we'll go back here to our assembly and we'll click on open up the cone driver. Insert components, browse. The cone driver is part number 7. So click on part number 7, click on open, and just simply drag it and drop it in that orientation. I'm happy enough with that. I'm going to click on mate and I'm going to select that the inside of the hole and the inside of the hole on the main housing are concentric, and then I'm going to select that the bottom of the cone itself and the bottom of the space in the housing are concentric as well, or sorry, it's coincident as well. Okay, so that's pretty much that. Yeah, I don't like that. I'll undo that mate. I don't like that because it doesn't look like that in the image. Okay, so we'll keep on going regardless. I think there might be a bush missing in there, but we'll keep on going. We'll bring it in like that. Okay, so we'll just drop it in there for the time being. We know that's concentric. It can move left or right. In the x-axis, it can't move forward or back. In the z-axis, it can only move up and down in the y-axis. So we'll figure out where its position y is later on. Okay, let's go and insert another component. The component I want to bring in is a copy of this, so I'm just going to hold down the control key, left click, hold down left click, drag and drop. Then we'll click on mate, and I'm going to select the diameter of the shaft and the inside of the hole. Again, it's the wrong direction for me, so I'm going to click on flip mate alignment. Okay, I'm going to bring the 2 of them here. Okay, so now we have the cones directly in. Now we need to find their position. So let's try and build up the rest of the stuff. So this vertical shaft is, what is it, part number, vertical spindle is part number 10. So we'll bring part number 10 and align it through the rest of the parts. So part number 10, open it up. insert components, part number 10, drag and drop that in, select mate, select the outside of the shaft, select the inside of the bottom of the hopper, and then we know that it comes up and it's just coincident to the top of this rubber bone. So zoom in, click on the top of it, click on the top of the rubber driver, and now there we go. So that's starting to get its shape. Okay, then we have to put in this bottom bit, which is the part number 9. Okay, and part number 9, we don't know the orientation of it, but we can assume that it is turned upside down to that configuration. Okay, again, it doesn't really matter, it doesn't tell us, so we can put it in whatever configuration we want. Insert component part number 9. Again, we'll go rotating it around, something like so. Insert components, click on the outside of the diameter of the shaft, the inside of the hole. Sorry, I wasn't making command. Click on the outside diameter of the shaft, the inside of the hole. Perfect. And then the outside of that sleeve, the outside face of the thing itself. Great stuff. Okay, so now we're starting to figure out this slowly but surely. Okay, so what we need to do is we need to try and get these aligned in some way, shape, or form. So the best way to do that is to be honest with you, because this isn't really going to be an assembly. Okay, we bring them up and see there's no size that fits there in terms of this. So the best thing to do would be to just line up visually, because it's a friction cone, so they're going to be touching friction wise. So when you have a frictional fit, it's neither concentric or tangential, because if it was tangential it only touched at one point. Really, this is a material, real life material, that's pushing into something, so it's existing in the same plane as another part. So the simulation here can't handle that, so as a result, generally we just kind of fix it like this. Okay, so you generally just bring it up till it's aligned, thereabouts. We'll put a make command on there, we'll click on that surface there and this surface here, and we'll come down here to this distance mate, and the distance mate is 34.92, so I'm just going to say 35, because that's going to push into it a little bit further, 0.8 of a millimeter further. Click on the green tick. Okay, and then this one here, the top surface of this and the top surface of that, again I'm going to go with my distance mate, I'm just going to make it 7. Okay, so that's giving me a good idea of where things are. So now it's not going to move over back, left or right, but I know that it's going to spin, and it's going to spin while pushing into the other friction cone. So again, a friction fit is kind of hard to simulate in real life. In virtual situations. In real life, it would be, if you could imagine, if you had a rubber or a razor from your drawing board, and you were to push your finger into it. It's really soft rubber, so your finger is pushing down into it, and as a result, if you were to take a bit of, if you remove that, your finger and the rubber across a table, it would actually dig into it. So again, it's hard to simulate. Okay, so the last piece then for this whole part is to insert the component, and we're going to look for, I think it's part 13, isn't it, which is the clear housing. So I'll just drag and drop that in there, select the make command. I'm going to select the inside surface of this, I'm going to select the outside surface of part number 13. That'll give me a coincident relation. Okay, the next thing then is to basically just pick that outside face there and the outside face of the actual hopper itself, or the cover itself, like that. Okay, and then the last one then is to come in here and select that bottom surface there. Again, you need to have your ability to be able to move the mouse around. See there, even I'm having difficulty trying to get it. And this bottom surface here. Yeah. So that's perfect, although you can see there's an issue here. I'm after drawing that, and it's a little bit shy of it. Now we're going to have to go and fix that problem. So again, this is how you edit something in place. Right click, open part, and we go up here to evaluate. So we click here on evaluate, and you click on measure. I'm going to measure this surface here from one side to the next. And I'm telling you there that is 122 millimeters. Let's go back and see what size it's meant to be. 122 millimeters. So I can see that this is the correct size. So part 13 is the correct size. So it must mean that the part number 3 is wrong. So let's go back to SolidWorks and open part 3 and see what's wrong with it. So let's go back here. Right click on the part number 3. Click on open part. And let's just see what size it is here. So let's measure the distance from there over to here. It should be 122 millimeters. And you can see it's 128 millimeters. So I was wrong by 5 millimeters. Let's go see where that problem is. So let's take the rollback bar, so the bottom bar on the feature manager tree. Let's roll it back the whole way to the start. So that's when time began. We started with a blank document. Then we cut a block. Put a hole in it. Put in a hole in the far side. We cut out the sides. Okay, so again, then we put the round on it, then we put the side on it, we mirrored it, then we got the bottom piece out. Right, so my guess is that up here, I miscalculated here on this extrude cut 3. Let's see what size that should be. That should be 122 millimeters here, we can see. So 122 millimeters, I would say, let's just check to see what size it was. I'm going to drag the roll bar down. So we've got extrude 3, right click, and we're going to go edit sketch. Let's see what size that was. So I did a 47 millimeters from each side. Okay. So I did 47 millimeters to each side, which is actually only to that line there. It should be 50 the whole way over. Okay, so let's go ahead and edit that. Again, parametric CAD being parametric, I should be able to edit these in place without causing too much hassle. Again, I say should be able to, we don't know. I'll click on measure again. That should be able to fix my problem because everything was relative to that last dimension. When I change that dimension, it should change everything accordingly. So that's 122 millimeters now. We're happy enough with that. We go back to the window, we go find our assembly, we open up in place, and you can see that gap is now closed up. So again, mistakes happen. Again, it's being able to know how to change them. It's looking back at that. So you'll see, just to recap on that, right click, open part, you open the part itself, then use the rollback toolbar to retrace your steps. This would be created a number of weeks ago, so I don't actually remember the steps I took to do it. We got to this point in the rollback toolbar, right click and edit sketch. We can go ahead and edit any of the sketches at any time. You can see there I changed this dimension from 47 to 50 and from 47 to 50, so that was 6 millimeters each side I was making up. Okay, and you can see how the mistake happened. I took a relative dimension over here, relative dimension over there. How could I fix that? I could have drawn a center line and I could have measured 122 divided by 2 each side of the center line. That would have been probably better because it would have required less maths, and maths is definitely not my strong point. Okay, so just again, that's how you fix your mistakes. Mistakes happen, but there's a huge amount of mistakes that you'll always come across in this type of stuff. So then if we press F on our keyboard, we can throw that around, and that's our finished assembled coffee grinder. The next step is in the next video to create a drawing with that, and we'll have to look at the explosions and that type of stuff and exploding it out to see all the parts, but that's pretty much where we're starting now. Okay, right folks, we'll see you again in the next video.